Hey nerds, we're checking out solving systems of equations, or as the British call them, simultaneous equations, through substitution. There's three methods, but we'll get to that in a second. All right, so solving a system of equations just means like you take two equations. Here's the blue equation, right? And if you graphed it, there it is. And here's the red equation. If you graphed it, there's the line. The solution is where they intersect, right? So in this case, it'd be 2, 5, 2, 5. And this is a solution. You often see the systems of equations that they look like this, and they have a fancy little bracket. Ping! And the solution is the x and y coordinate that when you put in the x, 2, 5, if you put in the x value into the x and the y value into the y, a solution for any equation makes this true. So in this case, this would be, let's move this piece. This would be 2 times 2, 2 times this 2, right, plus 1, and you put 5 over here for the y, and so this is 4 plus 1, that's 5, and does 5 equal 5? Yeah, ka-ping! That's why this is a solution for the blue equation. So is this point, right, like 0, 1 also makes the blue equation true, right? If you put it in, you'd get 0 plus 1 equals 1, and this makes the blue equation true. But this one doesn't make the red equation true, right? Because you'd put in negative 0, so 0 plus 7 equals 1. Does 7 equal 1? No, not usually. So this is not a solution for the red equation, which is why it's not on the red line. However, if you take what's special about this point is that it works for both the blue and the red. So let's try it with this, right? The same point, 2, 5. Here's the x, here's the y. Plug the x in, right? Negative 2 plus 7, and plug the y in over here, 5. And you get negative 2 plus 7. Hey, that's 5. Does that equal 5? Yeah, ka-ching! So this point is a solution to the system of equations, the simultaneous equations, because it works for both the blue and the red equations, makes them true. Ching. So why would you do that? Well, to solve problems that involve linear relationships running into each other and being equal. So here's an idea. Brad, blue, starts with €1, right, and steals 2 euros from an 8th grader every day. It means he gains 2 euros a day. So he's starting with 1, and then every day he gets 2 more. So at day 1, he has 1 plus 2 more, so 3. At day 2, he steals 2 more, so he has 5, etc., etc. So that's his line, right? Ray, red, starts with 7, but he's kind of a mess, and he loses 1 every day to a 10th grade bully. So it's not, bullying isn't funny. So he starts with 7, and every day he loses 1. Every day he loses 1, right? So you can see that this will be an equation, or a solution to the equation about when do they have the same amount. When do they have the same amount? Well, day 2 they'll have the same amount. How much will that be? $5. That's why 2, 5 is a solution to these equations. All right. You can use these. I use these like, I don't know, this is the 5th country that I've set up life in, and often you have to like have a data plan for your phone. Maybe not as much anymore because there's unlimited data, but here's an idea about when you might use it. You know that plan A starts at $30 a month, roughly, and it's 0.1, it's 10 cents per megabyte, right? So it increases at a low, or I guess at a high rate. The plan B is $90 a month, but it's free data, so it's just a flat line, flat rate. And plan C starts a little more expensive than this, right? It starts up here. It's more expensive than blue, but it charges less per megabytes, right? So it increases slower. So you can tell the points like, here's an interesting point. When is blue or black cheaper before 400 megabytes used? Well, blue is cheaper, so you'd want to use blue because it's below black, right? Before 400 megabytes. But after that, then you want to use black because black increases less quickly, right? So you can sort of look at them. The intersection points are interesting pieces. So one way to do this is graphically, right? Sketch the graphs, find the points where they intersect, etc., etc. That'll always work. It's always the easiest. It's always the slowest. So we're going to look at substitution today. There's a way called another method called elimination, but I'll let you look that up on your own in the extension work. So here's substitution, right? I reject your reality and substitute my own. Here's the basis of substitution. I want to solve for y, knowing that x is 3. Well, okay. Well, if x is 3, substitute 3 in, right? X is the same thing as 3. So put 3 in for x. Add y to it, you get 5, and then you can solve. Well, subtract 3, and y is 2, right? No big deal. Substitution means take something this is called x and substitute in its other name. Okay, so great. That's not too bad. Let's do the same thing here with this mess. So let's substitute in, if we know x plus y equals 5, and they say, I know that x plus 1 equals 4. Well, I can't play the same game we did exactly unless I remove this 1. So let's subtract 1, clean this up, and x equals 3. And then we can take x equals 3 and plug it in here and do the same thing. 3 plus y equals 5, so y is 2. Okay, fine. We're going to take those two ideas, kind of combine them, and solve this system of equations. Oh, circles, huh? So I want to figure out when these two equations are equal. Here's all the steps. You can look them up, write them down if you'd like. They should be in your notes. I'm going to go through them step by step, and hopefully they make some sense. We're trying to get, if we graphed them, I'm not exactly sure what these look like, but it'll look like something like that, and I don't know, something like that. This intersection point will be at 2, 1. Right? So that's one way to do it, is graph it. It's always the easiest. Grab some paper. It's always the slowest. Another way to do it is take one of these equations and solve for one of the variables. So this is another way to say x is all this stuff. X is equal to all this stuff. So if we take this top equation, and instead of calling this x, let's do it in green actually. Instead of calling this one x, let's call it x's nickname, because x is equal to 3y minus 2. So let's take 3y minus 2 and put it in there. So this equation, this top equation, if you substitute in x's nickname, you get 3 minus y instead of x's nickname, and then you still get plus 4y equals 6. Right? It's this same equation. It's just that x has its nickname. X is equal to 3 minus y, so we plug that in there. And then you can clean this up, and so you end up with 3 minus y plus 4y equals 6. We don't have to distribute or anything. This piece is negative y plus 4y, so there's 3 y's. Here's, and they're positive, right? This is this 3, and this equals 6. Subtract a 3 from both sides. Right, and you're left with 3y is 3, so y divided by, both sides divided by 3, you get y is 1, just like we thought. How do you get this x value, right? Because this is y, how do you get the x? Well, plug it into any one of these equations, right? We have two equations up top, so if we know y is equal to 1, we could put it in here and solve for x, or maybe even easier, plug it in there and solve for x. So I'm going to take this equation, let's do it in blue just so we can see it, and say, all right, well, x is equal to 3 minus y. I know that y is 1, so 3 minus 1, so x has to be 2, just like we expected. Great. Oh no, I can't watch. Let's try one more together, and maybe you'll feel better about it. Or if you like, try to go on your own. So I want to substitute in. I know that y is equal to all of this, so instead of this y, I'm going to call that y's nickname. So I'm going to take this top equation, rewrite it as 2x plus y equals 5, but instead of calling it y, I'm going to call it y's nickname, right, which is x minus 4. Right? It's this same equation, but instead of y, we're calling it y's nickname. And so now we've got 2x's and one more, so 3x's minus 4 equals 5, and so you add 4 both sides, you get 3x is 9. You divide by 3 and x is 3. If you're not sure how to solve that, come see me. Not a problem, but come see me. And then we pick either of the equations. They'll both work. I'm going to pick this because it looks simpler. So y equals x minus 4. Plug in your, this is what x equals, so put it in there. So 3 minus 4. So y is negative 1. So the point where these intersect is x comma y. And that's your solution. Whee! Cool. You try it, right? This one's a little tougher because you have to rearrange on your own. This one's a little more straightforward. Make it stop. Pause me and give it a shot. Go. Okay, so I'm going to, here's y, here's y's nickname. This is also y, so what you can do is take y's nickname and substitute him in here. So you get 2x equals x plus 5. Subtract an x from both sides, so minus x, and you're left with x equals 5. And then you can pick either of the equations, plug them in. So I'm going to use this top equation just because it looks easier. And you go y equals 2 times the x value, which is 5. Oh, fancy. D, spinny wheel of death. I wonder if we're... and then, so you get 10, right? Let's close that up, 10. If you pick the other equation, right, it doesn't like disturb the universe. Right? This should be 10, right? If you use this equation instead, let's choose green, and you said, all right, y equals x plus 5, and you put in this 5 over here, you get y equals 5 plus 5, you get 10 anyway, right? So either way, you should get this as your answer, 5 comma 10. Great, fine. With this second piece that's a little more obnoxious, what I would do is simplify for the easiest one. We wanted this to be y equals blah, 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 or x equals blah, 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 right? We want something pretty straightforward, and this is the easiest, it looks to me, to isolate. So I'm going to take this equation, x minus 4y equals 11, and solve for x. Right? I'm going to do that by adding 4y to both sides, and you're left with x is equal to 11 plus 4y. Great. So this is x's nickname, right? X can also be called 11 plus 4y. So instead of this x, we can call it x's nickname. You can't really do it with the one that you used, or you just get an equal solution, and it doesn't really make you don't get a solution out of it. So I'm going to choose this equation, right? Take the opposite equation, 4y minus 5 times x, and instead of x, I'm going to call it equals 9. I'm going to call it x's nickname, 11 plus 4y, right? And then what we can do is distribute this negative 5 in. Careful that the negative goes with it. The 5 is negative, so you still get 4y, but then negative 5 times 11 is negative 55, and negative 5 times 4y is, sorry, there, negative 20y's equals 9. Okay, fine. So let's see, then you have negative 20, you combine your y's, so you get negative 16y's, and on this side you get 9 plus 55, because you have to add 55 over here, add 55 over here, and so you get what, 64? And if you divide both sides by 64 and 16, negative 16, I think you get negative 4. Let's check. Oh, yeah, great. So this y value gives you negative 4. Once you're happy with that, then plug it into any of these y values, right? It's a y value, so y equals negative 4. So plug it in here and solve for x, or plug it in there and solve for x. And you should get out negative 5. Try that out, and I'll see you tomorrow. Bye.